We're going to discuss problem number 9 from web work in the homework. So this problem, we're looking for horizontal asymptote. So we are going to go over this in two different ideas. The first idea is what we discussed in class already, that if you know your rational function, you know one set of numerator and one expression for denominator, so you can identify it pretty easily. It's just about finding the leading term. Therefore, what we could have done is we could have tried to find this function by finding the shared common denominator, which is x squared times x plus 5. So it's x squared times x plus 5. And then my second term, I'm going to multiply x plus 5 to both the numerator and denominator. And my last term, I'm going to multiply x squared to both the numerator and denominator. So now you can see all my three expressions share the same denominator, so they can be combined together. It's 7x squared times x plus 5 minus 8 times x plus 5 plus 4x cubed divided by x squared times x plus 5. So it's just a matter of identifying the leading term of the numerator and denominator. So I'm no longer using equality. I'm just trying to single out the leading term. The denominator clearly has a leading term of x squared. Then let's look at the other pieces. This one is a cube term. This one has the highest order of x to the order of 1. It can't be the leading term. This expression, the highest order is 7x squared times x, so it's 7x cubed. It's going to be a leading term. So I have 7x cubed comes from the first expression, and 4x cubed comes from the second expression. So what we end up with is 11. My bad, my denominator is x squared times x to the 1, so it's x cubed. So I have 11x to the cubed over x cubed. So I end up with 11. So my final answer is y equals 11. And of course, this is just one way to look at it. We have other ways to look at it, which is a slight modification of what we learned in class. The first idea is a direct application of what we learned in class. The second way to modify it is to go with this. We've learned that by adding something to the function value, essentially, you're going to do a shifting either up or down. So what we could have discussed is it's actually three different expressions put together by either summation or subtraction. So if I find the horizontal asymptote of this one, horizontal asymptote of that one, and horizontal asymptote of this one, so it's just a matter of doing shift downwards and then shift upwards, then we can achieve my final answer. The first part, the function 7, the first function is 7, the second function is 8 over x squared. The third function is 4x over x plus 5. So if you look at their horizontal asymptote, the first function is a horizontal line. So itself is its horizontal asymptote, which is y equals 7. The second one, it's x of order 0 over x of order squared. So it's higher order on the denominator. So your horizontal asymptote is 0. The last term is 4x and x as a leading term. So its horizontal asymptote came from 4x over 4, which is simply 4. Therefore, to put everything together, the horizontal asymptote of the original function, keep in mind it's minus here, plus here. So you're going to have 7, 0, 4. But like we said, it's minus in the first piece and it's plus in the second piece. So what I end up with is 7 plus 4, hence 11. So again, you get the same answer. It's y equals 11 as your horizontal asymptote.